Okay. So today let us derive Reynolds equation in 2 dimension. Okay. So here consider that there are two non-parallel surfaces. This is one surface and this is another surface. Let us consider that this is the bearing surface and this is the shaft or journal surface. So shaft or journal surface will be moving, whereas the bearing surface will be fixed surface. Let H be the thickness of the mean thickness of the oil film, lubricating oil film. Okay, and let the shaft is rotating at a linear, shaft is moving at a linear velocity of, or this surface is moving at a linear velocity of u, of velocity u, and let w be the load on the journal or the shaft. Okay, so we are taking this coordinate system. This is x is in positive x direction, y is in the downward direction, and z is pointing towards the observer, okay, perpendicular to this plane. Okay, then let A be the moving surface and B be the fixed surface, and let us consider that they are inclined to each other at a certain angle. Okay, then now take a small infinitesimal element of the lubricant, a small infinitesimal element of the lubricating oil film, the film which is present between these two surfaces. Let us take a very small part of that film, and when you exaggerate it or enlarge it, it looks like this. Okay? These are the forces acting on that small infinitesimal cuboid. Okay, here P is the pressure acting on YZ plane. So Y is the plane in downward direction, Z is in this direction. No? So this is YZ plane. So P into dy into dz. That is pressure into area will give the force. No, so it is pressure into area, which is the force acting on this surface. Similarly, let us consider that dp by dx into dx is the differential change due to change in length from here to here. What is the length? Dx. So the differential change in pressure is, already P is there, plus change in pressure is dP by dx into dx. Okay, this is just similar to your, for example, suppose your bike can run at a, suppose your bike gives a mileage of say 50 kilometer per liter. Then suppose you have 5 liters of petrol. Then how you will calculate the total distance? 50 kilometer per liter into liter. No, it is just similar to this one. So dP by dx is change in pressure due to unit change in x into total x distance, that is dx. This is the pressure into what is its area again? Dy into dz. The area on which this pressure is acting is dy into dz. Is it clear now? This is the pressure force acting in the x direction. Similarly, force acting in on the top and bottom plane in x direction are shear stresses. Okay, these are the normal stress forces, and these are the shear forces. What is the shear force? Shear force is shear stress into area. Area is again dx into dz. The area on which this shear stress is acting, parallel stress is acting, is dx into dz. So tau x into dx into dz. We are taking all the forces that are acting in x direction only. Okay, in this case, what we are doing, we are taking all the forces acting in x direction only. Okay, now similarly, as on the top surface it is tau dx dz, on the bottom surface you have to take again differential change due to the distance dy. See here, tau x into d tau x by dy into dy. This is change in tau x due to change in the distance dy. Okay, into its area, the area on which it is acting is dx into dz. So these are all the forces we have represented which are acting in x direction. Therefore, for equilibrium of forces in x direction, what you have to do? Sigma fx equal to 0. Take the summation of all the forces, algebraic sum of all the forces. Algebraic sum means what? Sum with proper sign. Sum of forces with proper sign. Means if this is, you have taken positive and this should be negative, this should be positive, this should be negative, like that. Okay, sigma fx equal to 0. So first, this is the force P into dy into dz, minus this is acting in negative direction. So minus of P plus dp by dx into dy into dz, then plus tau x into dx into dz minus tau x plus d tau x by dy into dx into dz. Now let us multiply this. Okay, this is outside bracket, no? So if you multiply it here, what it will become? Minus of P into dy into dz. So here already plus P into dy into dz is there. So this is minus P into dy into dz. They get cancels. Okay, they cancel each other. Okay, P into dy into dz cancels each other. This is minus of P into dy into dz is there. Okay, they cancel each other. Here also tau x into dx into dz is there. Here minus of tau x into dx into dz. So these two will also get cancels. Now, what is the remaining now? Here it is minus dp by dx into dx dy dz. Then minus d tau by tau x by dy into dx dy dz. You can take dx dy dz common and send it on the RHS side. Send it to the RHS. So what you will get? You will be getting dp by dx is equal to minus of d tau x by dy. Okay. This is dp by dx is equal to minus of d tau x by dy. Okay, let us call this as equation 1. Now, according to Newton's law of viscosity, we know that shear stress tau is equal to minus of mu into du by dy. Okay. Now let us substitute it here. So dp by dx is equal to minus of d by dy of tau, that is minus of mu into du by dy. So minus minus becomes plus. Now d by dy of du by dy, that is mu into d square u by dy square. So if you send this mu on this side, it will become d square u by dy square is equal to 1 by mu into dp by dx. Let us call this as equation 2. Now integrating equation 2 twice with respect to y. Why? Because we want u. Now it is a double differentiation. Suppose you integrate it 2 times, it will become u. Okay. Okay. See here. If you integrate it once, so what it will become? Du by dy is equal to 1 by mu dp by dx into dy. So you integrate this. It will become 1 by mu dp by dx into dy. Integration of dy will become y plus any arbitrary constant c1. This is the constant of integration c1. Now integrate it one more time. So you will get u is equal to integration of this part, that is 1 by mu into dp by dx into integration of y is y square by 2 plus c1 into integration of dy is y plus an integration constant c2. Okay, so u is equal to, you will get this equation. Now you have to find the constants of integration C1 and C2 by substituting the boundary conditions. What are the boundary conditions here? At u is when y is equal to 0, u is equal to capital U. So to understand this, you have to go here. Here. When y is equal to 0, here. When y is equal to 0, y is positive in downward direction. So when y is equal to 0, so what is the velocity? Velocity small u is equal to capital U itself. That is the velocity of the plate. Okay. Then when y is equal to h, that is at this point, what is the velocity? This surface is stationary, no? So velocity is equal to 0. So when y is equal to h, u is equal to 0, and when y is equal to 0, u is equal to capital U. Is it clear? Here. When y is equal to 0, u is equal to capital U, and when y is equal to h, u is equal to 0. Now substituting these boundary conditions in this above equation, we get, first let us substitute u is equal to capital U and y equal to 0 in this equation. What it will become? So this will become 0 is equal to, this will become 0. This is also become 0. So it will be, sorry, u is equal to C2. Okay. That is C2 is equal to u. You got. Now let us substitute the second boundary condition. That is when y is equal to h, u is equal to 0. Okay. Substitute y is equal to h. So it will become 0 is equal to 1 by 2 mu dp by dx into s square plus c1 into h plus c2 is equal to u. Already you have got. Substitute it and simplify. You will get c1 is equal to 1 by 2 mu dp by dx into h minus u by h. Now you have got both the integration constants c1 and c2. Now let us substitute these c1 and c2 in equation 3. Then we get here. Substituting c1 and c2 in equation 3, we get u is equal to 1 by 2 mu dp by dx into y square plus minus of 1 by 2 mu dp by dx into h minus u by h into y plus u. Upon simplification, you take this as common, 1 by 2 mu dp by dx as common. So it will become y square minus h into y. Okay. Then here, this term and this term, that is in these two, u is the common. Take u is equal to common, u as common, you will get h minus y by h. Means after taking LCM, it will become 1 minus 1 by h. So you take the LCM, it will become h minus y by h. Okay, you will get this equation. Let us call this part, the first part or first term as u1 and the second term as u2. Here, this equation will give the velocity distribution across the section of the oil film. Okay. Velocity distribution across this section you will get. Okay. Now, in this one, second part, that is the second term, that is u2 is equal to what? U into h minus y by h. This gives a linear velocity distribution which is caused by velocity of moving surface relative to the stationary surface. This is the linear velocity of the moving surface. Then u1 is 1 by 2 mu dp by dx y square minus hy. It is a equation for parabola. Hence, u1 gives a parabolic velocity distribution due to the pressure induced flow in the oil film. Due to pressure induced flow. This we have discussed while discussing mechanism of pressure development in journal bearing in the previous class. So that was parabolic, no? The pressure generation generated was parabolic in nature. It is the same pressure, that is you are getting same pressure which is generated in the journal bearing. As the fluid has been assumed incompressible, you know that in assumption 6 we assumed that the fluid is incompressible, hence the volume quantity of lubricant flowing into the elementary cube is equal to the volume of lubricating oil flowing out of this cube. Volume of the fluid entering the cube is exactly equal to volume of the fluid leaving the cube. Hence, u into dy into dz plus v into dx into dz plus w into dx into dy, that is volume of fluid entering, is equal to its differential change in volume, that is u into du by dx into dx into dy dz plus v into dv by dy into dy dx dz plus w in plus dw by dz into dz dx dy. Okay. Now upon simplification again we get du by dx plus dv by dy plus dw by dz is equal to 0. This has happened because there is no flow in x direction. We have assumed that there is no flow in z direction. Hence means there is no end leakage. It is assumption number how much? Assumption number 1. The assumption number 1, we assume that there is no flow in z direction, that is there is no end leakage, so dw by dz is exactly equal to 0. Substituting in the above equation 5, we'll get dv by dy is equal to minus of d by dx of u. Now substituting the value of u from equation 4, just now here we have derived the value of u. Let us substitute it here. dv by dy is equal to minus d by dx of u, and simplifying, and we know that velocity is equal to 0 when y equal to 0 or y is equal to h. Means what? Was the velocity distribution here? Was the velocity distribution at y equal to 0 also it is 0, at y equal to h also it is 0, and it is parabolic in nature. Okay. Okay. Now substitute. We know that v is equal to 0 at y equal to 0 and also at y equal to h. So taking the integration of v over the area, that is y equal to 0 and y equal to h into dv is equal to 0. Now let us integrate the above equation. In order to integrate this dv, where is dv? Is here. dv by dy equal to d by dx plus d by dx into 1 by 2 mu dp by dx y square minus h y. Okay. So let us substitute it here and equate it to 0. After integration, we'll get 0 to h minus d by dx of u is equal to minus of 0 to h d by dx of this quantity into dy. Now let us simplify this one. Minus d by dx, let us take it as common. 0 to h dp by dx 1 by mu 2 mu y square dy plus d by dx of 0 to h dp by dx 1 by 2 mu h into y into dy plus d by dx of integration 0 to h u by h y into dy minus of d by dx of 0 to h u into dy. Now let us simplify this one further. That is, let us integrate this one. So we'll get this quantity. Now upon some simplification, we get d by dx of dp by dx into h cube minus 2 h cube by 12 mu into bracket complete minus d by dx of u into h by 2. Okay. If I send it on this side, RHS side, so it will become d by dx of this quantity is equal to u into dh by dx. Upon further simplification, you will get d by dx of h cube into dp by dx is equal to 6 mu sona 6 mu u. So now 6 mu u dh by dx. So this is the final equation for Reynolds differential equation. So this is the Reynolds differential equation which will give pressure distribution across the oil film. Okay, this is the Reynolds differential equation in 2 dimension for the pressure gradient in a converging oil film with no end leakages. You should remember that there should not be any end leakage. That is no flow in the Z direction. This equation may be used for determining the pressure gradient along an idealized bearing and consequently for determining its load carrying capacity. Once you determine the pressure generated, you can easily determine the load carrying capacity. So load is equal to what? Pressure into area. Okay. Then in case of bearings having parallel surfaces, H is constant and the value dh by dx will be 0. Hence, the right hand side of equation 5 becomes 0 and the pressure gradient dp by dx also becomes 0. This means that no pressure can be developed in such a bearing due to the relative motion of bearing surfaces. Means what? If you keep both the plates parallel to each other, then there will not be any built up of pressure between the two plates. So in order to build hydrodynamic pressure between the two surfaces, they should be inclined to each other. Okay.